All right, so let's talk about the soil moisture part of the homework assignment. I'm going to have you guys take a look at this irrigation, I don't know what to call it, article from CSU Extension Office. And what they have, what they have is a little article on estimating soil moisture. So quick facts about soil moisture. The idea is you can track your soil moisture if you're a producer to determine the timing of your irrigation. You want to maintain yourself in that allowable depletion zone, right? So you don't have less productive crops. So it can be estimated by feel and appearance of the soil. That's where you're doing those tests. And if you know the texture of your soil, then you can tell based on what you're able to do with it, how many balls or whatever snakes you can make out of it. You can get an estimate of the water content. You can also use devices to measure it directly, or I guess it's kind of indirectly, called a tensiometer. You want to check it at least one location for each field that might have different soil textures and slopes. So you can imagine you have a 100-acre farm, you're going to have different slopes, valley bottoms, areas with different geologies, and so the soil texture could change from place to place, and that's going to influence how much water is available for your crops. Okay, so I'll just walk you through how this homework problem is going to work. I give you some basic information. I think I give you the texture of the soil, so I say it's a sandy clay loam. So maybe you sent away a soil sample and you had it analyzed and they told you this is your soil texture. So it's a medium texture, a sandy clay loam. And then I said that this sandy clay loam forms balls and slicks under pressure. Okay, so this is the kind of different hand tests that you can do. It's a medium textured soil that forms balls and slicks. So that's going to tell us that our soil moisture deficiency is somewhere between 25 and 50%. 0% is fuel capacity, 100% is permanent wilting point, right? Okay, so now we know, and I say take the upper bound of that range. So we're at 50% soil moisture deficiency, and this is a sample you took from the first foot of soil. So then we can look at another table, and I gave you all these tables. The plant available water and average wilting point for your sandy clay loam. And this is in units of inches per foot. So your wilting point is 0.137 inches per foot. The plant available water under field capacity is 1.66. So this is the maximum amount of water you can have. And we just determined that you're at about 50%. So what we did is we took our soil texture class, we did this kind of hand test, we found out what the moisture deficiency was, and then ultimately with this table, figured out what our plant available water is initially, as well as maximum. So this is the maximum plant available water, and we're at 50%. And then the minimum tolerable soil moisture content, let's see here, is, I think that's 50%. Initial moisture.
Is there like a reason you choose that top value?
Right here?
For that description? For that
I just, you got to choose something. So I'm just telling you what to choose. You could be conservative and say it's 25%. So the way this homework works is you want to maintain your water content between the maximum available and the minimum tolerable, which is from this table right here. That's your minimum, or sorry, that's your wilting point. So the minimum tolerable is this minus 50%. And then your wilting point, obviously we don't want to get down to that. So for this problem, I'm giving you a spreadsheet and I'm giving you, so we have each day, we have the evapotranspiration from your crops. And I think I put in alfalfa or something, maybe I say in the homework assignment. I calculated this based on using the COAGMET, which is those weather stations. There's one out at Orchard Mesa, so that's where I got these data from. It gives you the location of that and the elevation. So you can kind of compare as your farm, at similar elevations and location to this. So there's a bunch of stuff I give you in the worksheet over here that gives you your initial plant available soil moisture. And so we kind of just calculated that, or I walked you through the steps to do that. So you put that number here, and this is where we're starting out with. This is our growing season, April 20th. How much moisture do we have in our soil? So I give you a time series of the evapotranspiration, and this is in inches. I should label that. Inches, inches, inches. So these are all in inches. And what your job is then is to say, okay, we've got evapotranspiration, we've got rainfall. There's also a rainfall record, how much rain fell on that day. I need to irrigate to make up for that deficit. So I'm going to have water leaving from evapotranspiration, I have water adding from rainfall. And so I'm going to basically start accounting for that water and make sure that I stay within those ranges that I said. So we start with our initial, and then we subtract evapotranspiration. We add any irrigation that we want to apply, and then we add any precipitation. So for the next day, I'm going to have, okay, what was my soil moisture from the previous day? And then I'm going to subtract evapotranspiration, add irrigation, add precipitation. And so I march down each day. So your job is to say, when do I want to irrigate and how much? Maybe it's not every day. And I give you some, I say you can irrigate at one time a week. You have 1,000 acre-feet of water to work with. And you have to figure out when to apply that irrigation and how much. So here's what that could look like. This is, I'm tracking plant available soil moisture in inches per foot. This was my initial condition. I irrigated, we started out pretty dry, so I irrigated, I bounced it back up. Evapotranspiration, started reducing it. I irrigated again, evapotranspiration, irrigated again, evapotranspiration. So you can see that as evapotranspiration starts to increase in the summer months, I need to irrigate more frequently to try to keep myself within or above this line. This is the minimum tolerable soil moisture, or MAD. So I irrigated above what is actually possible, right? That this would drain. I'm not accounting for the fact that a lot of this water could drain, but we're allowing it to stick around. So that's one kind of limitation of this. But we're trying to keep ahead of your evapotranspiration. We're not getting a lot of rainfall. As you can see, we get a little bit of rain here, so that helps us later in the month. So that's an overview of the homework assignments. I've recorded this so you can take a look at this again later when it comes time to look at it. And you're basically pretending to be a farmer that is using coag-met to keep the soil wet enough so that their crops don't die.